Sauce here. This is a video lesson for Python programming, sprite sheets. This lesson code started with stub2, but before we run it, I want to show you that I have graphic images in a subfolder called sprites. There are many sprite sheets in this folder. I'll show you one. A sprite sheet is a large graphic that contains many small drawings. In this case, there are 40 drawings of a warrior woman pointed to the left. That's arranged 8 drawings wide and 5 drawings tall. Each of these drawings is slightly different than the next. We use sprite sheets as graphic resources to create animation. A figure that is animated in a program is called a sprite. We accomplish the animation just like a movie accomplishes the illusion of motion by showing several still pictures in quick succession, each picture just a slight change of the one before it, so that our eye sees a smooth animated picture. What we need to do with our code is to load a graphic sprite sheet like this, create a whole bunch of surfaces, and on each surface put one of these images. And we'll store these surfaces in a dictionary. That dictionary becomes the resource that then helps us show these pictures in quick succession to the user. So what we're going to accomplish in this code is simply learning how to take the sprite sheet and prepare the sprites in a dictionary to animate later. Going to our code, we have 2 sprite sheets loaded as graphic resources. We called them sprite sheet right and sprite sheet left. The 2 sprite sheets we'll take a look at. This one that we just talked about are 40 images just for the movement to the left. We also have another graphic resource which is a reflection of the first, which gives us 40 images for movement to the right. So we've loaded 2 sprite sheets, one for left and one for rightward movement. Let's take a look at what we have so far before we get into how to write the code to prepare the dictionary of these individual sprites. We take a look and we have simply prepared one image, one single drawing of our warrior woman, and the words that describe what we're going to use as the key for the dictionary that contains this image. The graphics loop for this program is very simple. We do have a countdown in order to show different images in a regular cycle. We fill the screen gray, and we're blitting from the dictionary of warrior sprites that we've prepared earlier. So how do we prepare this dictionary? We do that outside of the frame loop, and it begins like this, with the comments. Under the heading or the comment, create surfaces and prepare sprites. This would be before the frame loop starts, but after we load our resources. We make the comment, there are so many. There are many, many sprites needed in order to make smooth animation look good. We need to make separate surfaces for each individual sprite, fill it with clear, then blit the sprite sheet at just the right location to get the sprite centered on its own surface. We have 2 variables, sprite width and sprite height. So if our warrior woman, a single graphic, is going to be centered in a surface, that surface needs to be 100 pixels wide and 150 pixels high. That means that whoever prepared this graphic sprite sheet needed to do a good job in making each image centered in 100 by 150 pixels, a rectangular space. And if these sprites are centered well, then it's mathematically reliable, and creating these surfaces is easier. If sprite sheets are not prepared well with the nice regular grid, then it can be as tedious as trying to find specific point locations, one for each image, which is quite a lot of work, so that you get your blit points correct. So how do we do this? We're going to do this with just the first image that we saw when we ran this program. It's a repetitive process. We have 4 lines of code, and we have the steps for those 4 lines of code, 1 through 4. Here is what these steps involve. We have the sprite sheet, which is the grid of many images, and we have a smaller surface that is just going to be one of those images. We need to create as many small image surfaces as we have sprites in the sprite sheet. We need to blit the sprite sheet on top of the smaller surface at just the right location so that it lines up and centers that sprite. The sprite sheet is going to give one of these graphics to the smaller surface every time we go through this process, and thereby form a collection of all of these individual images. So how do we get the correct blit points of the sprite sheet? With a little bit of math. Let's start with the first one. Number 1 in this process, we need to start with a new surface, which is the size of a single sprite. So we have the width and height here, and when we create a surface, we're using those dimensions. We're also running the convert alpha in order to include transparency in our surface. If the sprite sheet has been prepared well, it means that all of the drawings are on top of clear, so that when we blit the entire rectangle to the screen, everything that is not a part of the character image is clear, so that we can see the background behind the image that we're putting onto the screen. We need a convert alpha when we create the surface in order to be able to do that, to use transparency. The second step is to fill the new surface with clear. So our second step of code is to fill that with a tuple whose alpha value is 0, and so it'll be completely clear. Step number 3, blit the larger sprite sheet onto the smaller new surface at just the right spot to get one new centered sprite image. Now for this first one, we're blitting the sprite sheet left onto the surface that we prepared, sprite surface L1, L for left, 1 for this is the first in the series. And the coordinates that we blit the sprite sheet to, the smaller sprite surface, is 0, 0. That means that we are lining up the top left corner of our sprite sheet to the top left corner of our small sprite surface, and when we do, we'll get that first sprite in the top left corner. The first one's easy with that coordinate 0, 0. Fourth and final step in preparing one of our sprites, add that new sprite to the dictionary with the descriptive key. So we're creating a dictionary of warrior sprites, and we are adding the new surface that we just created into that dictionary of warrior sprites, and the key is descriptive, meaning this image is going to be for leftward movement, and it's also numbered as 1. It's going to be 1 out of a total of 40 because we have 40 individual sprites in that whole animation sequence. We need to repeat this process for every sprite. So I've done that. I simply need to uncomment it, and we'll take a look at what is similar and what has changed in creating our second sprite. We create a new surface, we fill it with clear, we blit the sprite sheet at a particular location to get a second sprite. Notice that the location changed, and it's descriptive. Negative sprite width comma 0. So again, back to our visual. If we're going for the second sprite, which may be this one in the grid, then what we want to do is we want to blit onto the smaller surface one sprite width back. So we're going in the negative x direction by the width of our sprite. And when we do, it'll line up horizontally onto that second sprite. Now the y location is still 0 because we're still working with the first row of sprites. After we work with the first row of sprites, the y location is going to have to be blitted in the negative y direction to get to by the height of the sprite in order to get to the next row. So every time we want to go a new sprite horizontally, we have to subtract sprite widths. And every time we want to get to new sprites vertically, we have to subtract multiples of sprite heights. After we do that for our second sprite, we add it to our dictionary with the new key, left 2. We have 2 sprites in our dictionary so far. Let's run our code and see if we can see them both. We have left 1, and there's an algorithm that has a cooldown and chooses randomly a new sprite, and we can see a subtle difference between these 2 sprite images, and we're also printing the key in the dictionary that describes what motion we're getting and what order they are in the sequence. Let's add some more sprites by uncommenting these sections of code. Here I've given an example of preparing the left 8 sprite. So if we have our sprite sheet that is 8 wide, then we would be getting this sprite here, the 8th one. It's still in the first row, but we've had to go backwards by 7 sprite widths to get the blit point that'll center that particular graphic on our sprite surface. So we go through this process, and here we have the blit point. 7 sprite widths in the negative direction horizontally, but no vertical change. And we call that left 8. I have several more examples to go through to look at. Notice there's an example for left 9, which after 8 would go back to the 0 or starting point horizontally. So there is subtract no sprite widths, but we do have to go down vertically by a sprite height. In other words, we're starting on our second row of sprites with the 9th one in the sequence. And here I have a couple of examples of using the other sprite sheet for rightward motion and examples of the blit points that would be needed for right 8 and right 7. Now these sprite sheets are reflections of one another, so when you're finding the position, the correct position in that sequence, you got to go in reverse order through the rows of a reflected image. We have to think about the math behind that. Notice that every single blit point prepared here is a certain multiple of the variable sprite width and sprite height. That's a very good way to go, so that when you change these blit positions, you only need to change the number in this setup in order to get to different blit points. I recommend coding this way to make it easy to copy and paste this code and then make different changes to get a different sprite. So if we were to have a complete set of left and right sprites, we would have 40 lefts and 40 rights. Too much to give example with in this code. This is just a beginning. Let's take a look at all the sprites that have been prepared so far. We can see, and if we want to press the space bar and quickly change, that we have several left and a couple of right sprites. They're all subtly different, and they all have unique keys which describe their position in the animation. This is just a beginning, and that is sufficient for this example code. If we are going to prepare a dictionary, we would do this kind of work for the 80 sprites necessary for these two sprite sheets, and we would do that in a different work in a different file, and then simply import the dictionary that was prepared. Again, in the future, this kind of code, which would be much more thorough, would be done in a different file to prepare this dictionary, and then our main program would simply import that single dictionary to be used for animation. And we'll do that in the next lesson. But for now, we have a Now You. A sprite sheet is a single graphic file that contains a series of smaller images, hopefully arranged in a regular grid, that are used to animate something in a program. You have seen how the sprite sheet was used to create smaller individual surfaces, each with its own image, and have the collection entered into a dictionary. The keys in such a sprite dictionary describe the image and its position in a sequence that would give the illusion of motion, of the sprite moving, if the images were shown in quick succession like movie frames. The more images there are in an animation sequence, the smoother the animation tends to look. Very few images were prepared in this example code. What was done is just a start. Add to this code by preparing a few more images from the sprite sheets that were used. Specifically, add the sprite image that would correspond to left 27 and right 40. The images with those keys cannot just be any in the sheet, they must correspond to the specific image that would be in those positions within the sequence. Have fun.